3Vision D. How to make most of your video surveillance installation without breaking the bank. Machine vision company with advanced video analytics. Their technology converts any camera to visual sensor that creates full 3D scene understanding in real time. Their awarded solution is automatic detecting and tracking in 3D environment, accurately reading object dimensions and position in real time. Mr. Mario Blaić, Chief Executive Officer at 3Vision D.
Hello.
Mr. Mario, welcome. Welcome.
Thank you. Thank you. We are happy to be here, and thank you for having us.
Thank you. Thank you.
Should
Mario,
I
you can. Yes, you can
I can start. Okay,
yes.
Great. Just let me share my screen. Okay. I will talk about us and what we do and what we will be doing, and to help the users and customers to make most of their existing video surveillance systems. So shortly, again, who we are and what we do, how do we see challenges in today's surveillance installations, and how do we see solution, of course. So we are the computer vision company. We are a software company. We come from the show business, where we have developed products based on our own technology, patented technology. Our main product was Vision Spot, which was automated tracking of performance with follow spot light. And while doing so, we have worked with some of the biggest names and productions in the industry. So I'll just give you a short clip of how does that look like. I guess you can recognize the performer, and you can see the lights that are following the performers on the stage, and they are not equipped with any kind of tags or receivers. So it's done purely by visual means. So how we have come to this solution? Well, we have had a request to automate the follow spot operations using only video camera as an input sensor, which was placed above the stage. And when we have been digging through problem to find a solution, we have found some basic problems in the computer vision. And that is that the camera image is not true representation of the captured image. There is a definite lack of one dimension, so we can't tell, and you can see this on the picture in the right, which is closer and what is who is taller. Yes, we as humans can do it because we have acquired experience and knowledge, so we have our own depth perception. But if you look at it on automation level, on the computer vision level, this is a flat image, and the computer cannot distinct the differences in perspective. Also, the pixels in the image and the real world position and dimensions are not at all connected. So all this is leading to a conclusion that we cannot automate the surveillance, and we rely only on human or simulated human oversight to be able to understand what is going on in the picture and what are the position of the objects in the picture. Therefore, we have come to a solution and to use a video camera as a visual sensor that reads 3D data from 2D image. And for that, we use the standard video stream as an input, camera parameters, 3D terrain. It's an important part, and of course the user map as well, which can be a geomap or CAD map. Through our algorithms, we then output dimensions of the detected objects, their exact location, being it either GPS or in meters or millimeters in relation to the camera. The system generates metadata, of course, and we use it to command the PTZ devices. And of course, we use the camera as a measuring tool, so we can exactly measure the dimensions of the detected objects, starting from pixel level to whatever object is detected. And we have all 3 X, Y, Z coordinates and measurements for the detected objects. So why is it important? Why we think it's important? I will talk about it now. So the common challenges in existing systems as we see them is, of course, the low quality footage, given that not all the cameras are good enough for forensic purposes. Most of the system installations today are passive, and they have a strong dependency on human factor, and humans are prone to have fatigue. They require training and they incur cost. And again, over time, we know that humans are effectively monitoring maybe 15 to 20 feeds for some time, and then the fatigue kicks in. So after a while, even with security officers on site, the efficiency in real-time prevention decreases. And of course, from the hardware standpoint, there are definite challenges with compatibility between different solutions, because in order to increase the level of protection and prevention, different solutions from different manufacturers needs to be deployed. So how is the industry today addressing them? Of course, there is AI-powered video analytics, which is a very powerful tool, and it's developing at a fast pace, but still today it is in its infancy, but something to be considered and definitely deployed. There is also a strong push for multiplications of the sensors, not only video sensors, but other sensors to increase the awareness and security of the site. There are investments in more staff training. And of course, there is a continuous innovation spurring to the market with new hardware and more capable equipment. But all this incurs cost. And the existing installations that customers, the users are currently using, are already being paid for and not fully utilized, which then makes the solutions today less accessible for the end users. So is it worth it? We think so, yes. But in order, before the investment this investment decision should be made, we have to understand what we want and what we really need. And then also to have a really sense check in answering the tough question: is it accessible? Is it reliable? Is it upgradable, and is it future-proof? Because once you make an investment, the idea is that this investment will serve over time and be a smart investment and pay off quickly. So our viewpoint on this is to have look at the essentials. When I say about essentials, I mean, what do we really need? I mean, why did we install the security system in the first place? So we want to have prevention rather than curing the consequences of illicit actions. Because this is when we can stop the damage or cost to happen. We want to have real-time situational awareness, what is going on all the time at the sites that we are surveying. We want to have as much automation of the existing systems as possible in order to be flexible and efficient. And of course, without any hardware upgrade needed, not only from the sensor point of view, but also from the system element point of view. And this is going especially to servers and other components which are critical for the functions of the system. So our solution to this is a 3D Smart Track, which is the first 3D video surveillance software product that focuses on operators, allowing them to manage the response rather than the equipment. And this system works with any camera or number of cameras. And as such has won the Innovation of the Year award by Milestone Systems. And we have won the Kickstarter competition last year. So allow me to demonstrate. This is a beta version on one test site to give you the idea how does it work. Of course, it's in the Milestone VMS environment. So let me walk you through. So here on the top right corner, you have a site. On the site, this is a JPEG image from Google Earth. Which has been calibrated to have exact GPS coordinates. Here are the placements of the camera. This system has 5 cameras, 4 ordinary cameras and 1 PTZ, which is here. And we have chosen this is a PTZ feed. This is stationary camera, and this is panoramic camera. You can see stitching and distortion of the image as well. So let me play it for you. So what you can see is actually when we move, we have enabled tracking, and when we move the cursor through the image, we have display of the position on the map exact, and we have automatic zooming of the objects and PTZ camera movement, which is not related. So basically, this camera here is providing metadata input for PTZ camera tracking. Of course, the system can have any number of cameras involved, and the idea behind is that we don't use the stationary cameras as a forensic mean. We use it just as a visual sensor. So this is where we detect object and then we use a PTZ camera or any other PTZ device, can be thermal camera as well, to inspect and inspect and detect, have a closer look on the point of interest or in the incident. Currently, we are moving the mouse around the map, and by moving the mouse around the map, PTZ camera is also pointing at the direction where the mouse is. This allows very fast sweeps of the very large areas, and gives you full real-time awareness what is going on, where is it going on. Of course, in the case of incident, we will have exact GPS coordinates of the incident, which can be then transmitted to either a security officer or somebody else to decide what would be an appropriate response level or response type to the incident that has been monitored. And of course, you have again tracking possibility using mouse over the video feed from the other camera just to simulate the functionality of the system. And of course, you have a GPS position or the position of the map, position of the cursor on the video feed over the map. So when we talk about main features of the 3D Smart Track, we connect pixels to geo coordinates to millimeters. So we are able to exactly measure all 3 coordinates of the pixel dimension and its placement in the real world. Having the map as an integral part of the system, we are able to put unlimited number of cameras and other sensors in the system. We just place them on the system, and whenever the sensor is activated, we will have the exact location of the activation, and the system will direct, if so program it, if so set it up, will direct all the available PTZ devices or other devices into that direction. The cool feature about the system is that the user is defining the map, so you don't have to pay for the license to use third-party maps. You can just take your picture of the Google Earth, or you can take a picture with a drone, or you can take your CAD map, or if indoor, and have it calibrated within the system, and to have exact position and layout of the site that you want to cover. This allows, again, fast sweep over video feeds or map for large area surveillance, and at all times you will be able to tell which camera and which position you are looking at. It is integrated with major open video management systems, and 5-step installation and calibration. It's rather easy for users, so it doesn't require additional work or specialized knowledge for this. Here is one example of the marina. The system allows also for multiple PTZ camera control. When the system is activated, all available PTZ devices will be pointed into that direction for maximum forensics and the picture. It is also important to say that the system allows for use of 3D maps like topography and CAD objects. So we will have the full 3D, we will have the full 3D understanding of the environment, which will again prevent some issues that are commonly occurring when surveying the large sites, and it will increase the detection accuracy and reduce the false alarms that could be triggered during the system work. So who does it need? Who is it for? Well, we see a number of use cases and advantages. It's definitely for the multiple sites monitoring. It's for perimeter control, for the access control, and definitely for the large area surveillance. With this, it's very easy to replace a number of security officers, which are either manually or physically checking out the sites, and decrease the number of operators in the security officers in the security centers who will be able to detect and to survey much more sites than what they do today, which will lead then to increased efficiency of the security officers, which will give the new functionality or make the existing equipment smart without need to upgrade the equipment. Given that we will use PTZ camera for verification and forensics, this will all the events will have high quality video forensics for the later use. With fast sweeps, there will be significant time saves, and of course the hardware requirements are so low that it works with existing hardware without any hardware upgrade need. So what we will be doing and what we are doing now, so the next steps is integration of the 3D filter. 3D filter is a video analytic tool that will enable users to decide to create the criteria for the detection using physical measurements of the objects of interest. For example, if it's a human, then we can put taller than 1.5 meter or 1.2 meter and wider than half a meter. We are working on alarm criteria management tool, which will be quite easy to deploy because there will be exclusion zones written on the map, not on the camera feed. So whenever something is detected in these zones, there will be a range of criteria that will be used for sounding the alarm or not. And of course, the metadata management, because system is generating a large amount of metadata, which we will be using it for the automation, for the forensics, and for the analysis. Here on this picture, you have a typical idea. So stationary cameras existing. which are used as a sensors for detection and location, and PTZ devices that will be used for automated tracking and using the location data from all the cameras. This will be done by June, and we are planning to be on the market available from June. Just to give you a glimpse of how does it work on the video analytics, this is an older footage from a different site. Here you have two cameras installed. This is PTZ device, this is stationary camera. There are objects that are detected. You can see the human here moving, and it's displayed on the map. So let me play it for you. It's a short one. So you have automated tracking with the PTZ. This is this one. Okay. Object is moving, PTZ is tracking. The PTZ device is not meant to be used this way. So it's a kind of a home device. Here we have an object detected that is coming into the scene of a stationary camera, is displayed on the map. And PTZ is tracking the object which is closest to the PTZ camera. This is the criteria that we have added. You can also see that the ball was not, although it was moving, it was not caught as a particular object of interest and being tracked by a PTZ device. So we invite you all to contact us. We are very much keen to have our solution tested. So we are looking for beta users for whom we have prepared a range of perks and special offers to help us to perfect the product, and hopefully you will find it also interesting for you to use it for yourself or for your customers. Thank you very much. Here are my contact details. I'm looking forward to seeing you in fall in Zagreb, where we will be presenting and exhibiting live. Thank you.
Thank you, Mr. Mario. Thank you for this awesome presentation. And we have two questions for you. I will start with my first. Is there a possibility to integrate the solution with other than Milestone YMS?
Yes, we will be, I will not name the solutions, but we will be implementing our solution with all the major VMS providers on the market, because we want to access the market and help users who are already using VMSs to have the functionality that we offer.
Thank you. And my second, how low light and camera parameters affect the performance of visual sensor?
Well, if camera sees, the system will see it. If camera does not see, the system will not see it. It's simple as that. So we cannot, the system cannot enhance the camera capability. It's very much like human eye. But in that case, if the system has, or the owners are willing to invest into like thermal cameras or something else, we can use that and have full functionality regardless of weather conditions or night or whatever.
Mr. Mario, thank you. Thank to TriVision.